long story short, there are no solutions to this problem. So that's going to jumpstart us into this discussion about absolute value equations. So today we're shifting gears a little bit. We're talking about absolute value equations, even though we've been talking about inequalities. So what do you think is going to come next? We're talking about absolute value equations, and we're in the inequality unit. What are we going to talk about tomorrow? Inequalities. Yeah. But first, we got to talk about absolute value equations. So, looking back at the warm-up, when do you think absolute value equations could have a solution? When do you think absolute value equations could have a solution? Wes, put your phone away. No, there's no excuse. Sean.
They will have a solution when they're positive, but also, absolute value equations always be greater than, x log is greater than whatever it is. And there's always be both positive.
So, not quite. When we get talking to absolute value inequalities, yeah. When we get talking about absolute value inequalities, you will see greater than, you'll see less than.
So will always be, unless the summation for the bars, will always be greater, x will always be greater than whatever number is.
Maybe. But maybe your question will be answered once we get further. So stay tuned, and then if I still don't answer it by the end, ask me again. Okay? So, Sean was exactly right. When you have an absolute value equation, it has a solution when, I'm just going to write this down. It's going to be kind of lengthy, but it's all important. So, absolute value equations, they can be solved if on one side all variables and constants are inside the absolute value symbol. And, big and there is a positive number on the other side. Actually, you're going to hate me, but change this positive to non-negative.
Zero.
So we can include 0. There's a non-negative number on the other side. So the subtle difference between positive and non-negative is positive numbers are all numbers greater than 0. Non-negative numbers are all numbers greater than or equal to 0. Sure. Scott. So, if this is the criteria for absolute value equations with solutions, what do you think the criteria is for absolute value equations with no solutions? Yeah, so this cannot be solved if, I'm going to just write same as first bullet point. So on one side, all of your variables and constants are inside the absolute value sign. And then the second bullet, there is a negative number on the other side. Right here, right here. Yeah. So, I lost my train of thought here. No, it's okay. Sean, go ahead, ask a question.
And also another question. So the question is the absolute value symbol on the bracket, like with all the order of operations.
Oh, that's a great one. I'm going to walk you through letter A here. And maybe letter B. And then you guys are free as well. So, the first step here when we're solving absolute value equations is, at least from the outset, we need to figure out if this can be solved. This one can be solved. So, how do you know that it can be solved? Yeah. So everything's on the inside of your absolute value sign on one side, non-negative number on the other side. Yes, can be solved. Check mark. So now, when we're solving absolute value equations, we actually have to break this up into two separate equations. I'm going to do it, and then we're going to talk about why this makes sense. So, the first equation you have to solve is the equation x minus 4 equals 7. And you have to solve the equation x minus 4 equals negative 7. Why do you think that is? So when you put something into the absolute value, yeah, you need to know how far away it is from 0. So, in order for this inside to have an absolute value of 7, x minus 4 must equal 7, or it can equal negative 7. So that's why we write both of these. So if you wanted to write kind of an or in the middle here, that'd be fine. So now, once you have these separated, you solve them just like you would solve normal equations. So you add 4 on both sides, so you'd get x equals 11, or add 4 on both sides, so you get x equals negative 2. And that's your solution. So then for B, what's our first step? Well, but even before that, Sean?
You want to make sure it's positive.
You want to make sure we can solve it. So can we solve this thing?
Yeah, then you divide by both sides of 2 and 4.
So now Kramer. So now I want to jump to Kramer's thing because you're skipping Kramer's step. So Kramer, what's our next step?
What we want to do is this equation, we want to turn it into 2.
Okay.
One of that equation is going to be 2x equals a. The other is 2x
equals negative. Now, going back to Sean's next step, we solve these just like we would solve any other equation. So divide by 2 on both sides, you get x equals 4, or divide by 2 on both sides, x equals negative 4. So there's really nothing to graph when we're talking about absolute value. Yeah, you can put points on the number line, but we're not really going to talk about graphing absolute value equations. What we are going to talk about, though, is graphing absolute value inequalities, which we're going to spend Wednesday and Friday on. So now, alright, so, letter C. Can we solve it? How do you know? There's a negative. So we've got our absolute value. We've got all of our numbers inside the absolute value on one side, and we have a negative number on the other side. There's no possible value for x that we can plug in to give us something that says you got negative. So this has no solution.
Would it be no willful determinant?
For now, we're just going to... Letter D, can we solve it?
Yes, we can.
Letter D, can we solve it?
Yeah.
Yes. Got all of our stuff inside the absolute value and a positive number on the other side. So, next step, split it up. Yes. So you should get x equals 5, or... Hey, let me tell you something. When you're subtracting two negative numbers, like negative 39 minus 4, well, you should get negative 43. A lot of you on your quiz put negative 39 minus 4 would be negative 35. That's not true. That's not true. So then divide by 7. You can totally leave this as an improper fraction. Actually, I encourage it. Can you solve letter E? Why not, Claire? You got your absolute value only on one side and then a negative on the other side. So, no real solution. What about F? Can we solve F? Totes. Can you put your phone away?
My name is Kramer.
I said, can you put your phone away?
Oh, I thought it was Kramer.
No. Kramer kind of got it out, but he's actually looking like he's taking notes.
I just wanted to talk to
So, yes, we can solve this. So we need to split it up first. Negative 4x plus 1 equals 25. Or negative 4x plus 1 equals negative 25. So, someone tell me what they did. Subtract 1. I'm just going to subtract 1 to all of them. So I get negative 4x equals negative 24. And then negative 4x equals negative 26. Probably going to want to divide that negative 4 from both sides. So I get x equals 6. No, that should be a positive 24. So negative 6. Or 6.5. Or x equals 6.5. If you wanted to leave that as 13 over 2, I wouldn't complain. So there you go. Not too bad, right? Okay. Now, you're not always going to have just the absolute value sign standing alone on one side and just a number standing alone on the other side. So we're going to have to do some work to get us to that point. Scott. It did say that. So some of these will be possible. Some of these will be possible. So I told you that an absolute value equation could be solved. You could only figure that out once you got the absolute values alone on one side and then a number on the other side. And then you could make that decision. So what do you think we could do? What do you think we could do to help us make that decision? Think about it. What do you think we could do in letter A to get us to the point to make that decision? Zach. Why would you subtract 9 from both sides? No, hold on. Let him finish. Let him finish.
Actually, probably the best. I don't know if you're supposed to multiply it by 2, and then you're supposed to multiply it by
So if I told you that this left side, we read this as 9 times the absolute value of x minus 7.
Same thing as
Yeah. Yeah. So what we're going to do here, is, since we want to get our absolute value to stand alone, we are going to divide both sides by 9. Whoa. So I get the absolute value of x minus 7 equals 29 over 9. I'm just going to leave it as 29 over 9. So now we're at the point where we can evaluate whether or not this can be solved. So can this absolute value equation be solved? Yes, it can. So now you take what you've got and apply the same process that we applied at the beginning. You're welcome to work with the decimals. I'm going to work with the fractions. And I encourage you, while we're going through the notes, to work with the fractions. And then once you get on the quiz, then you can do whatever you want. Yeah, so that's why I'm encouraging you to do it this way. So, we're going to split this up, so it's x minus 7 equals negative 29 over 9, or x minus 7 equals positive 29 over 9. So you're going to want to add 7 to both sides. So x equals, well, I know 7 is the same thing as 63 over 9. Huh? How do I know that? So this is the same thing as 63 over 9 minus 29. Huh? What are you saying? Okay, so the addition is 72 over 9, right? No, 92 over 9. X equals 92 over 9. So this would be 30. What did you say? 34? 34 over 9? And I don't know what that would be.
So it's, the other one is,
It would,
10 into 7, and the other is,
so it'd be 10.2 repeating and or 3.7 repeating.
so.
Ask Mr. Fisher. Alright, so letter B. You're not going to need to work with decimals this time. Letter B. Sky, what should I do with letter B? Okay. Just leave them as is. If you can reduce them, reduce them. But if you can't reduce them, yeah. So, letter B. How are we going to decide if we can solve this? So we get 3x minus 8, the absolute value of 3x minus 8, and that's equal to 4 minus 3, which is 1. So can this thing be solved? Definitely. We've got our absolute value standing alone on one side and a non-negative number on the other. So now split it up. We get 3x minus 8 equals 1, or 3x minus 8 equals negative 1. Now solve these equations just like normal. Add 8 to both sides. So I get 3x equals 9, or 3x equals 7. So I get x equals, divide by 3 on their side, x equals 3, or x equals 7/3. You are always going to have fractions. 90% of the time you're going to have fractions. But I've tried to help you out. So we're just going to take a quick note on absolute deviation. So, we're going to write this down. X, absolute value of x minus a equals d. So x represents possible values. A represents the accepted value. I'm sorry. And this D here represents this absolute deviation. So a lot of times when you're making products like a basketball or a baseball, it has to meet certain requirements. Like the NBA has certain requirements on the sides of the basketball. Major League Baseball has certain requirements on the sides of the baseball. So, like the NBA says, you need to have the basketball circumference needs to be 30 inches, and it can deviate. It needs to be 30 inches, but it can deviate half an inch on either side. So that accepted value is the 30 inches. So you would throw the 30 in for A. But yeah, there's a range, because there's always going to be like some manufacturer error, right? So that 0.5 window goes into the absolute deviation. So if I were to tell you that a regulation size baseball is 9 inches in diameter, and then it can deviate a quarter of an inch on either side, what are the minimum and maximum acceptable diameters of a baseball? How do we solve this? So x, we're obviously going to solve for x, right? What is our accepted value here? 9. And what's our deviation? 0.25. And then you can solve this absolute value equation just like we normally would. So x minus 9 equals 0.25, or x minus 9 equals negative 0.25. So you can add 9, add 9. So x equals 9.25, or x equals 8.75. Can't forget our units, which are inches. So the smallest baseball can have a diameter of 8.75 inches, and the largest baseball can have a diameter of 9.25 inches.